Hi, so last week we looked at rigid bodies, just a beginning initial look at rigid bodies, and we got some rigid body simulating quite simply. This week we're going to look at rigid body instancing. So we're going to use instances of an object scattered in an area, and then we're going to push that through a rigid body setup and get a dynamic simulation out of the other end. So there's a couple of steps extra to what we did before. It's still pretty simple. Pretty much any of you can do this. And yeah, so you've probably seen the example at the beginning of the video. So these objects here to create my lovely little scene, they came from fab.com, part of Epic Games, which you probably know it as Bridge, but it's not anymore. It's porting over. So I grabbed some of these. There's like a free environment which you can download. You get a lot of folders and a lot of objects and textures. And then if you have a look at the license, always good to look at the license, but you may use the assets commercially or privately, okay? But you may not resell. So we're not reselling anything. We are just using it commercially, I guess. But I'm not getting paid for this because I got demonetized because I didn't do any tutorials for a while. Thanks, YouTube. Right, so we've got our environment, which literally, just artistically, just push it together. Like, just grab some rocks. These are all duplicated of the same rock. I scattered them about to something that was aesthetically pleasing for me. Again, this is a duplicate of that. And the same here. And then there are a few floors in there as well, or ground areas, and again these are just pushed together and scattered around. And then I thought, do you know what, let's make a nice little camera move and give ourselves a bit of parallax, and then we can just sort of defocus and refocus, yada yada. So cool, that's honestly all that is. So I would go ahead and create yourself a nice little environment first, and while you're creating your environment, have a little think about where you want your rocks to fall. So in my instance, and we'll just do it from the top really, I'm just going to get rid of my cube here. I don't want any cheats. But if we create a polygon cube, we should all know how to do that by now. And we'll just scale it up a bit. And this is basically going to be our volume or our container for our rigid objects. And I'm going to put that up here because I'm like, okay, so this is where my rocks are going to be. And they're all going to fall from this area. And we're not going to be able to see the cube, so it doesn't matter. But from about here, they're all going to drop. And the deeper the cube, and the more scattering I have within that volume, because that's what it is, or will be, the more those rocks will kind of stack up and fall for longer, and thereby last for longer. Right, so I'm going to have this about here. And then what I'm going to have a little think about is this object here that I've brought in. I've actually sculpted this a little bit so that we can get more of an area where the rocks can kind of fall or pick up a bit of velocity or bounce against. So I'm just going to go into the sculpting tool, and here I might want to make something interesting. I might want to make a lip here where the rocks kind of roll and then they drop off, or they don't, or they just sort of sit there, and then all throughout the simulation we can adjust this, and so we get something that's pleasing to us. And so yeah, I mean we're creating kind of like a funnel here for the rocks to fall down, which is quite nice because then you'll get like a stream of rocks happen here, and some kind of pushback here. And again, the rocks below these will be colliders also. Gives us some interest, gives us some kind of areas for the rigid bodies to bounce off of. And when you're happy, and you can go back and change this at any point. Always best, I think, delete your history. And then we're going to grab all of our rocks, which I believe are everything here, and we're just going to make one massive collider. So I'm just going to middle mouse drag that into the Bifrost graph. By now you should have created a new Bifrost graph, which if you don't know how to do that, you would literally, a couple of ways you can do it. Just go new graph, like so, and you get a new graph, an input and output, or if you just open up Bifrost, and you'll go to the Windows graph editor, there'll be a button for you to press that says new graph. But we don't need this new graph. I'm going to carry on using this graph. I'll show you what that is in a minute. Okay, where was we? Colliders. Right. Let's grab all our colliding parts, and I'm going to middle mouse drag them into here. I've already done that. That's what the, that's what the input is. I got confused. I got confused with an input because we just looked at an input. Right, so these are colliders, and nothing's going to happen right now with it. Oh, and in the background here, I've got an Arnold Sky Dome with a HDRI on it, which probably at some point I got from Polyhaven. So shout out to Polyhaven. Okay, so input by path. Right, now let's get the volume working first. So we're going to keep that down here, and let's just rename it. I don't know what we're going to call it. Collision objects. There we go. Let's get W in there as well. Collision objects. Let's leave it. Let's leave it. I like it. It's a weird faux pas, but so here is our emitter. We're going to drag that in. Okay. I call it an emitter. It's not an emitter at all, really, but it is where we're going to get emission from. Why does everyone want me all the time? I even actually closed WhatsApp, so I didn't get any notifications, but whatever. Say hello to Stu, everyone. Right, so here we go. We've got stuff about to happen, so it's a good time to pause the graph, right? So control and period or full stop if you're speaking the English language. And we're going to get a let's have a look inside. Let's have a look inside the Bifrost browser, right? Because this is sort of semi-important. So if we go into rigid bodies inside the Bifrost browser, we can see that we've got a rigid body instances example. Okay, if you double click that, you can open that. It's quite complex, so it might take a little time to open. But it's more about the Maya viewport, I hear, at the moment, that sort of slows things down, which is being worked on. Anyway, that will open this bad boy here. And the best thing to do whenever you sort of start rigid, any Bifrost graph really, if you're not 100% sure, always check the Bifrost browser first to see if there's anything in there that's similar, and then it starts to give you clues, if you're not 100% sure what you want to do. So for me, I was like, right, I want to create instances. I've seen a rigid body instances example. I wonder how they are doing the instances, and you get, there's a lot to look at, but you can figure out in here, okay, well, we're going to need to create a standard create instance node, but that goes into a set rigid property units node. They've got a compute on frame, which you may or may not use. I don't use in this instance. But how did they scatter? Oh, okay. They've got a scatter inside mesh. A scatter inside mesh. Right. So if I look for a scatter inside mesh, and press caps because for no reason. Right. Scatter inside mesh rigid. There's only one there because I made one. Right. But it doesn't exist. There's not a scatter inside mesh. So this has just been written in this way, scatter inside mesh. So in my head, it's like, well, we're trying to scatter inside a volume, right? We've got our object, we've pulled it in, and I'm going to hit scatter, right? I'm hitting the tab. I'm just going to type the word scatter, and I want to scatter in volume because we want to scatter some things into a volume. So I'm going to drag that cube into the input here, and if I unpause the graph, control full stop, and give it a second, we're going to see a bunch of coloured dots show up here. Too many for us, right? So look, we've got 64,000. Let's take that down to about 25. And while we're here, no, let's wait a second. Let's keep that at 25. Let's change the look of them from disk to point. Cool. And then I want them to be absolute to the resolution of the cube. At the moment, they're relative. I want to be absolute. And then when we hide that cube, we can see that we've got points that fit in the shape of that cube, and I'm just going to take up the amount now to like 100, and we can see, you know, that's where the cube would be. Let's just keep scrolling up here. That's where the cube would be, right? That's going to be too many points for us for what we're doing, but that's our volume. So we want to take it right down, because these are the areas in which we're going to attach our rock, and our rock is down here somewhere. I've lost it because it is merging in with everything else. That is not it. I thought I had it. Okay, our rock is actually here. So there's our canyon rock, and I'm just going to drag that into the scene. Give it a second. And then we're going to pause the graph again, because it's just easier to move around within the graph. So we've got this scattering volume, we've got a rock here. Okay, so now we would want to instance all over the points that are there, right? So we're going to start typing instance, and we want to create instances. There we go. And anytime we create instances, we want to create instances node. And so we're going to take the points into the points, and we're going to take the mesh into the mesh, and then we're going to create a little output, because we need an output to see things. There are other ways, and we're going to plug that in there, and we're going to unpause graph, control and full stop period, and then we're going to see a bunch of rocks scattered into this area here. Now, these rocks are tiny. If we go back to our original, if we look at our original rock here, we can see it's a lot bigger. Now, the reason they're tiny is that they are following the scattering volume point size. Okay, so if we go down to the point size and see it's 0.25, if I press 1, et voila, they are now the same size as this. Okay, so that will be one reason that later down the line, if you know, once you've created your rigid body setup, and they are not contacting or simulating in a way that you think they should be, that will be the main reason they're not. It's because you've got a different point size to your input. Right, so here are our rocks, and we can notice, oh, by the way, the rock is textured as well, right? I just threw on any texture that actually came off of one of these, so it's the wrong way of doing it, but that's how I did it. So there is a texture on that, and as we've brought it in, it has kept the texture on those instances, yeah, which is good for us. But what we want to do now is mix up the kind of position and rotation of all of these, yeah? So if we hit the tab, we want a rotation, and we want to randomize the rotation, randomize point rotation. Okay, so think about it, we're randomizing the points, not the object, because we are actually using points here. Okay, so we're going to randomize the point rotation, and we'll kill this, and we will drag this into the points. Give that a second to think about it. Should probably be pausing the graph here actually, and then we can see we have got right out of the box, you know, some randomized rotation. Now you can crank these numbers up and down, max and min, to what you desire. So I might want to go minus 0.4, and that's going to change them even more in Z, and then I might want to do the same in X, and you can just kind of intuitively play around with it like that. Okay, I'm just going to pause the graph because we're going to bring in another one now. So now I want randomized scale. So that's sounded condescending. I was talking to children, didn't it? Randomize. If I sound like a little bit full on at the moment, it's because I just said a workout. I implore anyone that sits at home all day to work out, because it just gives you this incredible rush, and you guys are at the brunt end of it today, I'm afraid. Right, randomized point scale. There we go. And we are just going to drop that in there. Points, out points. So the way that I did that was just hold the Alt key, dragged it, hovered it over the top, and then you can select the inputs and outputs, but you can do it the old-fashioned way as well. So unpause. And now we can see we've got different sizes of those rocks as well. So we have randomized the scale of those rocks. And again, we've got a min and a max, and if I take down the min, we get like really tiny small ones, which is quite nice, and obviously if I take out the max, we're going to get much bigger ones. All right, so now that is all good. Right, So we've got our rocks. If we press play now, absolutely nothing whatsoever is going to happen because we do not have a rigid body dynamics set up. But there is another step we need to do because we can't just feed in this rock into here and then send it all to the RBD solver. We need to tell the RBD solver that this rock here, that is the instance of over all of these points, is dynamic. Okay, and so we are going to add a where's my thing gone? A rigid body instance. So we want to scroll down here and we want to rigid body instance, drag that in and drop it in the graph, and let's just out drop geometry rigid body instance, and it does itself a small favor and connects itself. So we've got a rigid body instance going into our instances. Okay, that's the first part. Let's just move this out of the way. I'm going to drag this out of the way because that's potentially for later. And now we want to create our rigid body, a basic rigid body graph. So I'm just going to start typing in rigid body, and then we'll just go with basic rigid body graph. It's coming in. Awesome. And now let's pause the graph because we're going to be doing a little bit of work, and right click and explode. So in a normal rigid body graph we would use a rigid body here, okay, but this time around we're using these instances, and so what we don't want to do is plug these instances into this rigid body here, because we've already told it that we've got a rigid body here. So we just need some properties, and so for that we want to use, and this will become second nature when you've done it a few times. Create rigid body. Where's the properties one? Properties. Set rigid body properties. There we go. And so we're taking the points in the instance and we're plumbing that into the set rigid body properties, and we're going to plug that into where the rigid bodies was plugged into the instances point of the simulate rigid bodies. Okay. Right. So next up, we're going to need our collision objects, right? And because they create us with a static collider already, we could just plug that straight in. And we can have a little look at that static collider while we're here. Bounciness, I want that right down, and friction. I'm good with friction, but this is rock, so let's just put it down a bit. The only reason I'd have friction here is just to control the simulation a bit more. But you know, if you think about rock, friction is not so high. So in this instance, anyway. Okay, this is looking good. Let's turn the P off there because we don't want to preview the scatter. How many scatter points have we got? 132. I think it's a bit high. It was good for us when we were looking at the cube, but let's take this down to about 25. Okay. And then, just like setting off a firework, we are going to simulate. So let's put another output here. No need for a shader at this point. Out instances into an output. I'm going to kill this, control and alt to use the knife cut tool, whatever you want to call it. And I am going to unpause the graph, control full stop period. And we can see our rocks there, and I'm going to rewind, and I'm going to make sure that I'm set, playback speed is set to play every frame. Cool. And we're going to hit play. Let's see what happens. We have got rockage falling. Yeah, it's looking good. We can adjust this, obviously. But yeah, let's try it. Let's try to get a better look with more rocks. So because this is like a procedural setup, we can just go back into the scatter volume and we can say, right, let's have 100 rocks, please. And 100 rocks appear as if by magic. A lot easier than AI, I might say. And let's rewind and play. Yep, cool. This is looking good. And you see that area I was talking about earlier, that funnel? We do have a funnel of rocks coming down there, which is looking kind of cool. But if we want to kind of like mimic the one that I did, see, I told you this was easy, guys. If we want to kind of mimic the one that I did, let's make a couple of changes. So let's just pause the graph. Let's increase the depth of this and kind of drag it up a bit so they've got further to fall, thereby creating some more velocity. Obviously, you can model this if you want to create a completely different shape, or if you want them to start up here, go for it. Like, it's all you. So let's get rid of that, and I'm going to go wild because we can see that it's, you know, it's behaving quite well at the moment. Let's go 200 rocks and unpause the graph. Let's just pull Bifrost out of the way. Rewind. And play that bad boy. And you can see, like, this is not a slow simulation. You know, this is pretty good. So now we can take it a step further if we want to. And first of all, let's just have a little tidy up. Let's just drag this here and here and here. And with this, I don't know, with this section here, I'm probably going to say, right, this is my little rigid body section. So let's create a backdrop and just call this rigid. And then this little section here is my little scattering section. So I'm just going to create a little scattering section. And I might leave this rigid. No, let's bring it all in together, actually. Let's bring it all in together. Let's call this little section here our scatter section. Scatter in vol. That's what we did. And then there, I'm probably just going to add another little backdrop and just call this rigid body instance. And then all of this reminds me, going forward, if I ever use it again, of, you know, what's what and what I use for what. And it's also just easier on the eye. I can just, you know, bosh, rigid, bosh, scatter area. There we go. Bosh. Right. So let's fracture everything now, because why not? Like, these rocks have had too much of an easy time for too long. We're going to go in and we are going to fracture the hell out of them. So, to do that, I kind of had to play around with this myself and figured it out, because I don't think it's in any of the graphs, fracturing instances. So let's just take out the points from the instance and the instance geo and bake it, because if you don't bake it, the Voronoi fracture didn't like it, right? So we are going to undo this, cut, and drag this into the instances. And so we're baking all of this, and then we are merging the meshes, and we're adding the Voronoi fracture. And let's just have a look at the fracture before we start simulating, right? So let's go up to around here, and I'm going to hit D for the diagnostics of the Voronoi fracture and see if it's doing its thing. It's going to take a minute. Because it just does. Here we go. And at the moment, this Voronoi fracture, I've got this set fairly low. But when you bring in a Voronoi fracture, it'll probably come in quite high. So let's just go Voronoi fracture mesh. And I think by default it's about 100. So you may wait longer, but yeah, right. So we've got 40. So what this enables us to do by having a diagnostics on is to go in and see how our rocks are going to fracture, where they're going to fracture, and where they're going to break, basically, within this. Now, if you want to wait more time for your simulation, we can up this number to get more breakage going on, or perhaps you want big chunks still, you know. We can move this fracturing around as we've seen before, but if I do put that up to 100 and wait for a second, because obviously it's doing something fairly complex, we'll be able to see that there's just going to be more chunks happening. And this is scattering over the whole volume. Oh, sorry, this is fracturing over the whole volume, right? So if you imagine a pattern, like a fracture pattern, Voronoi pattern going on here, we can, over the entire volume, we can understand just how many more points we need to add to create like finer fracturing. There will be other ways, but we can see that even some of the small ones have got fracturing going on because they are basically just hitting the cut point of the fracture of the Voronoi pattern. I mean, so anyway, let's get rid of that diagnostics. Don't need to see that anymore. And what we do is we kind of go back on ourselves and we use the rigid body create rigid bodies node again. Instead of the properties, right? So these new guys we're just going to have sit in here. I'm going to keep convex hull on there. So we've got bake instance geometry coming straight out of create instances, Voronoi fracture, and create rigid bodies. We'll move the properties for now. I think we'll just move that out of the way. Let's move our output over here, and I'm just going to plumb that straight into instances. So now we rewind and play, and we should get some fracturing going on. If you click, you can usually get an idea of where the fracturing, if you look at the actual mesh, you can usually get an idea of where the fracturing is going to occur. I'm not 100%. I might need that properties node, but let's take a look. I'm just going to kill my animation on this perspective camera for a second because I just want to actually see the point in which we hit here. And then we're just going to play, right? So let's just concentrate on a few of them, see if this fracturing is going on. Hit play. Everything is slower. So as expected, in fact, if we want to be like testing this, let's go back to our scattering area. And let's just turn our scattering down a little bit so we can, test this. Because why test it on 1,000,000 when you can test it on 20? And hit play. Sorry, I should just hit rewind and play. Go. See if we see any fracturing going on. Bosh, straight away. Here we go. Fracturing is occurring. Woohoo! That's a lovely thing. So rewind, just so you can see that close up. Rewind and play. And crack. Bosh. Snap. Amazing. Shards and fracturing all over the place. So that is working. And now we can just go and up the amount that we want. Slow everything down and sit here for half an hour. Simulating while we have a cup of coffee. Actually, it's not that slow, to be honest. So rewind and play, and we should have a bunch of fracturing going on. And that is about it. So like I said, I don't think there is an instance to fracture graph in there, so I had to kind of like figure that one out. A bit of trial and error, but it all kind of makes sense really. So basically, you just have to bake your instance to get it into the fracture. I'm sure there's another way, but that's what we did. And so now, with that fracturing going on, we've got lots more like smaller pieces happening. So I think what I'm going to do is do a little play blast, and we can look at what that means for us. And I'll come back in a minute. And there we go, fracturing. We've got some nice like shards going on, stuff like that. All these little bits of almost like slate cracking away and coming down. So this is awesome. This is just what we want. And yeah, go forth and start to use instancing and fracturing. And I'll come back soon with another tutorial on taking all of this further. Cheers.